Okay, so here we are for the afternoon session. So this morning we talked about a bunch of stuff, right? We talked about flipped classroom, requirements and guidelines, Python fundamentals. So the assignments for today, please try to get these done by the end of the day. It gets a little crazy from this point on, right? So the assignments start stacking up. So get the easy ones, and not saying these are easy, but make sure you stay on top of it, because if you fall behind more than 2 days, it's very difficult to catch up. So make sure that you do the core assignments, and once you're done, please submit them. Okay, so submit them on the platform. Do the assignment tracker on the calendar. Make sure you update that, but primarily make sure you submit them on the platform. So this was optional. So I talked about Python syntax, data types, Booleans, numbers, strings, none. Now we're talking about the composite types. Okay, so the composite types are lists, tuples, and dictionaries. So starting with lists, a list is basically an array in every other language, right? So the array operations we can do, array functions that are available, I should say list functions that are available, are similar to other languages. So if we have a list of fruits and a list of vegetables, and I declare a new variable and assign it to fruits plus vegetables, what am I going to get if I print this?
A new concatenated list.
Yep. Basically, it's just the plus operator will work on arrays just as it does on numbers. It'll just add the two together. So if I have fruits and vegetables, and I take salad, and I say 3 times vegetables, what am I going to get when I print salad?
An error.
And an error. So strings, lists under the hood, right? Python is written in C. C, basically a string is just an array under the hood, right? So it keeps track of all the different characters in a string. So list and string operations are the same. So just like we can concatenate strings, we can concatenate lists as well. So yeah, it'll just print the vegetables array 3 times. Okay, so it just sort of multiplies it and spreads it out. Okay, questions about that? All right. So if I have my list 0, 1, 2, 3, 4, 5, I can access the different parts of the list, right? So lists are stored, basically there's a hidden 0, 1, 2, 3, whatever, however many items are in the list, right? So if I say my list and I grab the first item, right, or the 0th indexed item, what am I going to see if I print this? Yeah, 0, right. What if I do list 3? My list 3.
2.
Not 2. Because I've made the values the same as the indices. So this is 0, this is 1, this is 2, this is 3. So if I grab the item at index 3, I get 3. Okay, what if I say my list 6?
Get an error.
Error, right? Because we are out of range, right? So there's no 6th element. So if I try to grab something outside of the list, it's going to throw an error. Okay, this is a good thing, because there's a way hackers will, if they're able to access what's beyond a list, then they can basically get whatever's stored in memory right after this list ends. And that's an old, I think one of the worst hacking incidents ever was because it wasn't controlled, the access wasn't controlled, and they were able to get beyond the list, and basically what was beyond the list was everybody's user info. So this is a good thing. This prevents us from accessing items beyond the list.
So you can't add items beyond the range? Like you can't say my list at index 8 equals something? Like, will I just add something onto the very end without?
I think it might.
Like, will it fill in the spaces? Like if you said my list,
Some languages will.
fill
Some
in.
languages will fill in. Like if you say index, let's find out.
I know sometimes it'll just say like they're empty, but then that 8th index will have something.
Yeah. Is this the right one? Hold on, I think this is the wrong one. I'm all messed up now. Give me 1 second. How goes? That's why I was getting that error before. Where is it? There it is. No, that's not it. There it is. That's the right one. Okay, sorry about that. Let's see. So if I say you guys still see my screen, right? You see me typing?
Yep.
Okay, so if I say 1, 2, 3, and if I say my list at index, so I have 0, 1, 2. If I say my index at 5 equals 9, right? I don't get an error. So let me see, print my list. Where am I? I'm in Dict. It's in here. Yeah. Oops. Index error. Yeah. So you can't do that. So it'll say list index out of range. So you can append, right? You can say my list append, but it won't let you assign later on down the list. There is a language that lets you do it. I can't remember. Maybe it's Ruby. I don't remember, but that's will fill in the gaps. But yeah, this you can do this like for like dictionaries and stuff like that, but you have to go in order when you're appending. Good question. All right, let's see. Okay, now we have string slicing. So this, list is this one, 99. They bark every day. I apologize for that. So what am I going to get when I print this?
A copy of it?
Yeah, this just makes a copy of the list. So if I do this, what am I going to get? Okay, I built up the anticipation enough. I get 4, 2, 5, and -3. Anybody know what's happening here?
Slicing.
Mm-hmm.
The
From the
first.
starting index.
Yeah. So if I give it the starting index and I say colon, it's just going to assume that I want from this index all the way to the end. Okay, so if I say 1 colon, it's just basically saying, give me this index and everything till the end. Okay, so if I do this, what am I going to get?
You're going to get the beginning of the list through the 4th index value.
Yes. Yeah. So it's going to give me from the beginning all the way to the 4th index, which is 0, 1, 2, 3, 4. But the 4 isn't inclusive, right? So it's up to, but not including 4. So basically what's happening here is if we have a list, and again, I just make the values the same as the indices just for simplicity. When you're slicing, you're basically doing the same thing you're doing with a range. You have start, stop, and step. Okay, so if I have, if I leave these off, right, it's going to assume that the start is 0. It's going to assume that the stop is the end, and then the step is basically if I want every other item. So I could say 0, 10, and 1. It's going to say basically just do the same thing as the empty like just the colon. So this will just basically give me a copy of the list. Okay. And so we can also append. So when we say we have nums.append, it'll add 10 onto the end. So if I print nums, oops, if I print nums, it just tacks 10 onto the end. Okay. Any questions about lists?
For the append function, if it's not a number data type, you'd feed in a different argument, correct?
Yeah. So in Python, you can put anything into a list. You could put numbers. They don't have to be all the same data type. Other programming languages won't allow you to. You have to have a list of numbers or a list of strings. But Python, you can add anything. It's not the best practice in the world. You should probably keep your lists homogeneous, like only strings or only whatever, but it can be done. Okay. Any other questions about lists? All right, so the next topic is tuples. Tuples is kind of a funny name. I say tuples, some people say tuples. I think it's like a potato thing. It doesn't really matter. But tuples are basically Python's immutable version of a list. And when I first started, I was like, why would you have an immutable anything, right? Why put this restriction and make it more difficult, right? But tuples are very useful because you oftentimes, it will prevent errors if data can't change, right? So if we want to protect data and not have it be alterable or have it be altered inadvertently, then tuples are very valuable. It's hard to see their utility in the outset, but once you've been programming for a while, tuples will be your favorite, I promise. So this is an example of a tuple, right? So if we have a dog, we don't want its genus and species to change, right? The dog string could be whatever, carnivore, and then 12 could be the age, right? So our dog, we can never basically add anything. If I say dog.append, you know, a value for is cute, right? I try to say true, it's going to give me an error, right? Because tuples are immutable. So if I say dog equals what I had before, and then I try to tack on domestic, what's going to happen?
We have it written, it's just gonna be the full list, and then it's gonna just add domestic as another list, it looks like. 'Cause
Right.
then
So it's taking dog, right?
which is all
And
that.
it's adding domestic to it. So how does that work? Why it's supposed to be immutable, right? How am I able to update dog?
I don't know, I thought it would have been outside that list. It doesn't look like it's gonna get put in there, but
Yeah, but it works like a list, right? If I said, you know, dog, you know, 1, 2, 3 plus 4, 5, 6 in another list, it would just join them together. So tuples work the same way, but they're immutable, right? How is this able to work?
So you can add elements, you just can't change any of them? Is that how it works?
Concatenation, it's a new object.
Yeah, who said that?
I did.
Oh, Ben. Okay, don't.
I thought
Right,
immutable
so-
meant you can't update the object.
Right. So if I tried to add, right, if I tried to say dog and dot append domestic, it's going to throw an error. It's not going to let me do it. But basically, we're creating a brand new object. We're reassigning the variable dog to a new tuple. So it allows us to do it. So if
the
I,
system
the
doesn't
way this
recognize
works,
dog the
sorry.
way it did in the previous line,
I'm sorry?
but it doesn't recognize dog the same way it did in the previous line. It's saying, let's just set up a whole new list, essentially.
Exactly. So first I start out with my dog, right? Assigned to this tuple. So the ID function in Python will give you basically the memory address where an item is stored. So if I print the ID of dog here, and then I do my reassignment and I print the ID again, I'm going to get two separate numbers, right? So basically it's recreating or it's eliminating this dog, taking it down here, reassigning it. So now dog has a completely different address. So it's as if this is going to sound horrible. I don't want to say, I'm not even going to say it. Basically, I got rid of one dog and made a whole new dog with the new data. Does that make sense? Okay. Any questions about tuples? Okay. Let me.
Corey's got it.
Corey had one in chat.
I'm sorry, Corey.
Oh, you kind of answered with that last sentence, I think. They're not competing anymore, right? The new one just completely overrides it.
Right.
Okay.
Right. So yeah, you're right. They're in the same scope, but this is basically dog is a variable, right? And variables vary. It's perfectly acceptable to reassign a variable to something else. I could now, in the next line, I could say dog equals tree, right? It doesn't matter. Yeah. All right, let me.